So the next thing that's in this extensions booklet is determine the roots and the vertex. So you're given a standard equation, standard form or general form, and you're trying to find the x-intercepts and then the vertex. So the first thing we're going to do is find the x-intercepts, and we're going to use the quadratic formula to do that, or we're going to factor if we can. So it depends on whether you can factor or not, but I'm going to use the quadratic formula here just to show you how that part works. So b is 11, so it's minus 11 plus or minus the square root of, and then b squared, so 11 squared, minus 4 times a, which is a half, times c, which is 12, and we're going to divide that all by 2 times a half. Okay, so we get minus 11 plus or minus the square root of 11 squared is 121. And then half of 4 is 2 times 12 is 24. So we get minus 24. And it's all divided by 1 because 2 times a half is 1. So that's going to give me minus 11 plus or minus the square root of 121 minus 24, which is 97. Okay. Now, 97. I need to see if there's a perfect square factor of 97. Okay? Because if you scroll down here, you can check your answer and you can see that there's not. But remember, we looked before at simplifying that. So if I can simplify the square root of 97, I should. In other words, if I can find a perfect square factor that was in a 97, I should, but I can't. So those are my two x-intercepts. So my x-intercepts, if I want to write them as actual coordinate pairs, are going to be minus 11 plus root 97 and 0 and minus root 97 and 0. Now, it also says find the vertex. So once you know the roots, because a parabola, is symmetrical, then the vertex has to be directly in the middle of the two x-intercepts. So if my x-intercepts are minus 11 plus root 97 and minus 11 minus root 97, then minus 11 is in the middle of these two. Okay, because basically what I'm doing is I'm saying I'm starting at minus 11, I'm going plus root 97 to get to one of my x-intercepts, and I'm going minus root 97 to get to the other one. So minus 11 is right in the middle. And that means my vertex is at x equals negative 11. Now that's not the whole vertex. I have to find y, but y is this. So I just go y equals 1/2 times minus 11 squared plus 11 times minus 11 plus 12. So that gives me y is equal to 11 squared is 121. 121 divided by 2 is here. That this gives me minus 121 because it's 11 times minus 11, and then we add 12. Okay, and if we take our calculator, if you want to do it this way, we can go 121 divided by 2. We can subtract 121. We can add 12. We get minus 48.5. So my vertex is, as a coordinate pair, minus 11 and minus 48.5. So once you found the x-intercepts, the vertex is always in the middle, right? It's directly in the middle. So it's the midpoint. And you should have done some stuff with midpoint in grade 10. You should remember that. But the midpoint, if you don't remember that, the midpoint formula is x1 plus x2 divided by 2, and then y1 plus y2 divided by 2. So if you're trying to find the midpoint, you're really just focused on this. You just take your two x-intercepts, add them together, and divide by 2. Okay, so that's how you find the x-intercepts of the vertex of a quadratic equation or function. There's a bunch of them here. So let's just scroll down. We'll try another one. So let's try this one here, this 8x squared minus 42x plus 72 equals 2x squared. So the first thing I'm going to do, pop that over. So it's going to become 6x squared because I'm going to subtract 2x squared here and subtract 2x squared there. And then it's minus 42x plus 72 equals 0. So what I'm then going to do is I'm going to try to factor this if I can. That's divisible by 6, that's divisible by 6, and That's just what 6. So I'm going to go 6 times x squared minus 7x plus 12 equals 0. Okay, so then if I solve that by factoring this time, that's x minus 4 and x minus 3. Excuse me. So my two x-intercepts are x equals 4 and x equals 3. So I can write them as 4 and 0 and 3 and 0. Those are my x-intercepts. Okay, so the roots are 4 and 3, and that corresponds to the x-intercepts that are 4, 0, and 3, 0. So then to find the vertex, you take x to be the midpoint. So you take 4 plus 3 and divide by 2. So you get 7 divided by 2, and that's 3.5. Okay, so just the two x-intercepts, add them together, divide by 2, that's my x. And then my y, I go back up to my equation, which I'm going to use this guy, all right? And I'm going to go 6 times 3.5 squared minus 42 times 3.5 plus 72. I'm going to see what that gives me. So I'm just going to take my calculator, go 3.5 squared. We're going to multiply that by 6. And then we're going to go minus 42 times 3.5. And we're going to add then 72. And we're going to get minus 1.5. So our vertex is 3.5 and minus 1.5. Okay. And again, the answers for all these are down here. So you can, there's my answer there. But I think that's the one, letter E. Anyway, you can look at the answers on your own, and they should match, all right? So hopefully they do. And some of them are weird. If you look down here, some of them are like, they've got roots in them, a couple of them, okay? So I will leave it up to your teachers to go through those with you in a little more detail maybe, but some of them are pretty easy. If you get an x-intercept that's actually the same, if both x-intercepts are the same, like it's not 4 and 3, it's actually 4 and 4, then that's also your vertex. Your vertex is also at 4, all right? So that's how you find the roots and the vertex from an equation, okay?